So you should have had the lesson by now on solving a system of equations algebraically, or you could say solving it through elimination. It's the same thing either way. This is right after, so we did solving a system of equations by graphing, where we graphed two lines, and then wherever the lines crossed, if they crossed at one spot, that was the solution. If they didn't cross at all, they were parallel, then there was no solution. And if both lines were right on top of each other, then that meant there were an infinite number of solutions. Then we went ahead and we solved with substitution. Now we're solving a third way, and this is called, again, solving algebraically, solving a system of equations algebraically, or solving a system of equations by elimination. So I have some problems that you'll see on your worksheet by the time you watch this, if you're reviewing. I'm just going to solve all of these out. I'm going to give you a little bit of explanation, but mainly I'm just going to go through solving different problems. So I'm going to rewrite the problem for, there we go, 4x plus 8y equals 20. And I have negative 4x, this is the second equation, plus 2y equals negative 30. So just like we talked about in the lesson, and just like we've done in other types of problems where we've solved the problem by writing numbers underneath the current equation that we have to get rid of terms or combine terms, we're really just doing the same thing. So I am basically going to take both of these equations. So again, I have equation 1, and then I have equation 2. Two separate equations. I'm going to combine these into one equation, and my goal in doing that is to eliminate one of the two variables. Now, the first couple of problems are already set up to eliminate the variables. So I don't really have to do anything. So you'll notice if I make a line right here, this is my equals line, if you want to call it. And I'm going to combine these vertically. So I'm going to say 4x plus negative 4x. Then I'm going to say 8y plus 2y. And I'm going to say 20 plus negative 30. So I'm just going straight down each column. I'm combining them. So if I combine these two numbers right here, 4x and negative 4x, they actually just come out to be 0. Because a negative 4x plus a positive 4x just cancels each other out. Just like negative 1 cancels out positive 1, negative 4 cancels out positive 4. Well, now I have a plus sign. That's the next piece of it. And I have 8y plus 2y. Well, that just combines to be 10y. Now I combine positive 20 and negative 30. That combines to be negative 10. Well, now my new equation is down to just one variable, and I can solve this if it's just one variable. So my next step is I need to divide both sides by 10 in this case. That divides out to 1, and I get y equals negative 1. Negative 10 over 10 is negative 1. I'm not done yet. We always have to solve for both variables. So next, I have to figure out, well, if y equals negative 1, what is x equal to? I can pick either equation to do this. I'm just going to pick the top equation. I'm not sure either one is much easier or harder than the other one. So if I know y is negative 1 right here, in the top equation, I'm just going to replace the y with negative 1, just like we did when we did substitution. So I still have 4x, nothing changes there. So everywhere I see a y, I'm going to replace it with negative 1, just like it's circled here in blue. So I did have y times 8, but now instead of y times 8, I'm going to make it negative 1 times 8. That's going to equal 20. So now I have 4x plus negative 8, or you could say subtract 8 equals 20. Scroll down a little bit. Whoa. What in the world is it doing? I don't understand what it's doing. Oh, there we go. Okay. So now my next step is I need to get the x all by itself. I leave division for last, so I don't want to do anything with the 4. So I need to say plus 8. That goes to 0. Plus 8 over here gives me 28. So I bring down the 4x. So 4x equals 28. I'll divide by 4 is my last step. I get x equals 7. So my final solution then would be y equals -1. And oh my goodness, what's wrong with this thing? So it would be y equals -1. Whoops, I'm sorry, I don't want to do it that way. My solution set would be 7, comma, -1. Or y equals -1, x equals 7. All right, so there's the first problem. I'm going to have to I'm going to go ahead and erase that since it's a recording, because you guys can always go back and watch that over again. But I'm going to go ahead and erase the ink on that one. All right, so now I'm doing problem number 4 as it's listed here on my sheet. Second problem I'm doing now. So we write the equation, -6x plus 5y. Ooh, that was an ugly 6. -6x plus 5y equals 1. I have 6x. Oops. 6x plus 4y equals -10. So just problem number 4 down here. These are already set up again. If I make my vertical line, I'm going to add vertically. These two just cancel out. -6x plus 6x just goes to 0. I have plus sign there. 5y plus 4y gives me 9y. I'm just combining those. 1 plus -10 gives me -9. So now I would divide by 9 so that those would divide out to 1. If I divide by 9 there, over here, I get y equals -1. Again, I need to solve for both variables. If y is -1, I could say -6x plus 5 times. So I'm going to replace the y with -1. And then just equals 1. So again, look at the top equation. All I've done is I've kept everything the same. So this is in the top equation. This is in the top equation. This is in the top equation. That's in the top equation. That's in the top equation. The only thing I've done is I've replaced the y right here with -1, because that's what we solved out and said y equals -1. That's all we've done. So now I can just keep solving the equation. All those marks. And I would say, again, save division for last. Well, here, let me do this step. -6x plus -5 equals 1. And I would say, okay, save division for last, so I need to add 5 here. If I add 5 there, I got to add 5 here. That gives me 6. That all cancels out and goes to 0. And then I just bring down the 6x. So I get 6x equals 6. Divide by 6, divide by 6. That divides out. I get x equals 1. So my solution set for this one is y equals -1, x equals 1. So I would just write it as an ordered pair, x equals 1, y equals -1. So that would be my solution set for problem number 4. The second problem that I've been here. All right, so let's do the, can I move these? Oh, nope, that didn't work. So we've done this problem. We've done this problem. I'm going to erase the ink. And let's grab the next problem. So I'm going to bring this problem up a little bit higher. Oops. There we go. So we're working on problem number 6, the third problem we're doing here. All right. So 8x plus y equals negative 16, negative 3x plus y equals negative 5. Now, here's our first problem. Here's our first tricky problem. If we try to add these vertically, so I put a line here, I add them up, I would get 8 plus negative 3x is just 5x. But then I would get y plus y is 2y, and that would equal negative 21. Now that's mathematically correct. We can do that. The problem is it doesn't help us any because we still have two variables. We still have the x and the y in our equation. We can't solve an equation if we have two variables. So we need to just back up. Bag it up. Bag it on up. Back. I need to somehow change one of the equations so that it will wind up canceling out with the other equation somehow. One variables. This just comes with practice, but in this one I can immediately see that I have two y's, no coefficients for those two y's. So if I could somehow just make one of those a negative y, it would cancel out with the other y, and I can do that. The way that I do that is I'm going to multiply through by a negative 1 on both sides of the equation. I hope I can do this and slide this to the right a little bit, maybe. Yes, I can. Great. So I'm going to multiply both sides of this equation. And this is where it gets tricky. So this bottom equation, do it in red. I'm going to take this and multiply it by negative 1. If I do it on the left-hand side of the equal sign, then I need to do it on the right-hand side. So I'm going to multiply by negative 1 over here. Now, if I multiply through, and this is just using the distributive property that we've been working on, negative 1 times negative 3x, do this in blue, gives me a new equation of 3x, positive 3x, negative 1 times positive y gives me negative y. I could have said plus negative y, same thing as subtract y. Actually, I am going to say plus negative y. So let's go with that. It gives me plus negative y. And then that is going to equal negative 5 times negative 1, which is just positive 5. So in this case, since I was multiplying through by negative 1, all that really happened is I just flipped the sign of everything, if you'll notice. Negative 3x went to positive 3x, positive y went to negative y, negative 5 went to positive 5. That's pretty much what happens when you multiply or divide by a negative 1. It just flips the sign of everything. Well, now I can combine this equation, this new equation. I'm going to rewrite the very top equation. So 8x, it doesn't matter which one's on top and which one's on the bottom, still the same equations, equals negative 16. So now I can combine these two and one of my variables will cancel out. The y will cancel out. So if I add these vertically, 3x plus 8x is 11x. A negative y and a positive y combine to cancel out and become 0. So that's plus 0. Negative 16 combined with positive 5 gives me negative 11. So my next step now, I'm going to do this, I guess, in the long version. I can bring down 11x. I don't need the plus 0. That equals negative 11. Clean it up just a tiny bit. So there we go. That's a little better. So 11x equals negative 11. I divide by 11 so that those divide out to be 1. Then that means I got to divide by 11 over here. And that gives me x equals negative 1. Not done yet. That's only one of the two variables. You go back up to one of the original equations. 8x plus y equals negative 16. Go back to my black ink. 8x plus y equals negative 16. If I know x is negative 1, I can simply say, okay, well, everywhere I see x, I'm going to replace it with negative 1. And plus y equals negative 16. That gives me negative x plus y equals negative 16. In order to get rid of the 8, I say plus 8, which makes that go to 0. So all that just cancels out. If I add 8 over there, I got to add 8 over here. So that gives me negative 8 over here. So I would bring down the y. So this y just comes down. I got rid of the 8s. So I have y equals negative 8. So my final solution for this one in an ordered pair would be negative 1 is what I solved for x. It's right there. X equals negative 1. So that's where I got that from. So, I don't know what's going on with my screen. There we go. Negative 1 is my x value. And then negative 8 is my y value. So that would be my ordered pair. Pretty sure I did that. Yeah. I can plug it in real quick if I went back up here to the top. So if x is negative 1, that would be positive 3. Positive 3 plus negative 8 would give me negative 5. So that works. All right, so we did those first 3. You have 3 examples. Here's the last one I'm going to do on this. If I can figure out how to scroll. There we go. So drag this. Oopsies. Drag this all the way up. There we go. So I'm doing this is the last example. This is the hardest one by far. All right, so my equation that I'm going to start with is this number 10 here. I'm going to say negative 4x plus 9y equals 9. Then I have x subtract 3y equals negative 6. All right, so again, if I add these vertically, nothing cancels out. I would get negative 3x as my first column. I would get positive 6y as my second column, and then I'd get positive 3 as my third column. Now, there's actually 2 ways I could do this. I can see, again, this will just come with practice. If I multiply through by a 4 on both the left side and the right side of the equation, so if I multiplied through by a 4, I see that I could get these 2 to cancel out. Because I would have positive 4x. And again, I would just be multiplying the bottom equation by 4, not the top equation. So if I multiplied the bottom equation by 4 on both sides of the equal sign, I would get positive 4x. And then I would get subtract 12, because I have to multiply the 4 times the negative 3. And then I would get that equals negative 24, because I'd be multiplying 4 times the negative 6. I could also, though, I can see I could multiply through by a positive 3 on the bottom, and that would actually give me a negative 9y, which would allow those 2 columns, or those 2 variables to cancel out. The positive 9y would cancel out with the negative 9y. Doesn't matter which one you choose. Eventually, like I said, through practice, you'll start to come to recognize these things. I'm going to go ahead and just multiply through by the, I think I'm going to do it by positive 3. We'll just stop it by positive 3. So this equation, doing it in red, I'm multiplying this by positive 3 and this by positive 3. You can do anything you want to an equation as long as you do it on both sides of the equal sign. That will keep it in balance. Again, just like if we had a seesaw, we could add 4 kids to one side as long as we added the same weight to the other side. So the same You can add 2 kids, 3 kids, 4 kids, doesn't matter. As long as you're adding the same weight to both sides, it keeps it in balance. Same thing here. I can multiply by 3 on the left-hand side as long as I multiply by 3 on the right-hand side. That keeps it in balance. All right, so anyway, my new equation here is 3x. I'm just doing the distributive property, 3 times x, and then 3 times negative 3y. Subtract 9y equals negative 6 times 3 is negative 18. Now I'm going to write the original equation again, negative 4x plus 9y equals 9. So this one cancels out really nicely. I get negative x here, because negative 4x plus 3x is negative x. That all goes to 0, so plus 0, and that's going to equal negative 9. Negative 18 plus 9 is negative 9. Now I have negative x equals negative 9. That is not the solution. I'm not done. Right? I need to just get x, positive x equals what? So again, the way I do this is I can divide. Remember, the last step is division. Little tricky, but what I'm going to divide by is negative 1, because technically there is a 1 next to this x. We don't show it because we don't really need to show it, but technically there is a negative 1 there, so I divide both sides by negative 1. That now gives me the positive x I need, and it means there it says x equals 9. I need to solve for y. I can plug it into the original, I can plug it into either equation. So I see x subtract 3y equals 6 right here. This is the equation that we're working on, or this is the system of equations, number 10. So if I know that x is 9, oh, there we go. I could say, all right, I'm going to go to green. Well, I know that x subtract 3y equals negative 6. That comes from this equation right here. But I also know that I just solved out an x equaled, make a better x equaled 9. I just solved it out and got that. So I'm going to replace the x in my equation with 9. And I'm going to say, all right, well, then that means 9 subtract 3y equals negative 6. Well, now I can solve it out. I saved division for last, so that means I subtract 9 first to get rid of it. So that all goes away. I subtract 9 there. I got to subtract 9 there. That gives me negative 15. This is my middle of the seesaw, so whatever I do on the left, I got to do on the right. I'm going to bring down the 3y, so I get negative 3y. Don't forget about the negative sign, by the way, there in front of the 3. So I get negative 3y equals negative 15. My last step is I divide by negative 3. Don't forget the negative sign. If I divide that by negative 3, I got to divide this by negative 3. I got to do it on both sides. That divides out to 1. Leaves me with just y. Y equals positive 5. So my solution was 9, 5. That was my solution. Now, if I really want to, I'll do it real quick in my head. 9, 5, if I do the math, if x is 9, 9 times negative 4 is negative 36. So I have negative 36 there. If y is 5, that gives me positive 45. So if I have negative 36 plus positive 45, that does give me positive 9. So I'm going to get it right. That's the first video I've done, just basically solving a bunch of problems from the worksheet. I'm solving a system of equations by elimination.